All right, guys. So let's do number 14. There we go. Three forces acting on an object are given by the equation. So F1, F2, F3. And the object experiences an acceleration of magnitude. So I'm not going to use my own notation. For now on, I'm just going to use the traditional standard vector notations that you guys used to, um, just to make it easier for you guys. So let's write this down. So F1 is going to be negative 2 newtons in the I hat direction plus 2 newtons in the J hat direction. F2 is going to be 5 newtons in the I hat direction minus 3 newtons in the J hat direction. F3 is going to be negative 45 newtons in the I hat direction added to 0 newtons in the J hat direction. So these are your vectors. Or I like to think of them as points, but whatever. But in the traditional sense, vectors are not defined as points. They're defined as like magnitude and direction, or whatever. So here we go. Sorry, folks, that's my condition. Anyways, so you have three vectors. The object experiences an acceleration. So three forces are acting on the object. So you have a force, one object, it's going to be negative 2, 2. So that's going to be maybe 40. I think that's 45 degrees right there. And this one is going to be 5 newtons and negative 3. So maybe it's like down here somewhere. And then here is going to be negative 45. So this is going to go all the way up towards that. So I don't know. It's poorly drawn, but it doesn't matter because we are going to find the resulting force. So the resulting force F is going to be F1 plus F2 plus F3. So all you have to do is add the components together. So once you add the components, you should have negative 42 newtons in the I hat direction. And then this would be negative 1 newtons in the J hat direction. So the resulting force is really this magnitude right here. So it's going to be 1 newton and negative 42. It's going to stretch out. It's basically practically a straight line in the horizontal direction. So there's a resulting force. So part A, so let's just answer the questions now, because we can get everything else. What is and the object experienced acceleration, let's write that down, at 3.75 meters per second squared. That means that we can find the magnitude of that force. And let's do that. Let's find the magnitude so we can get the mass and get everything else organized. So we're going to use the Pythagorean theorem, folks. I'm pretty sure you know what the Pythagorean theorem is. That's going to be 42 squared plus 1 square, or the square root of whatever, 42 squared plus 1 square. I'm just going to put the end result. And the end result here would be 42.01 newtons. Now, I do want to make it clear, we are talking about, this is really just the magnitude. I'm not sure if I should call that negative or not. But I don't really care, so I'm just going to leave it as that. So we're just going to pretend the magnitude is pointing in that direction. So anyway, so there's a magnitude. So once you have that, what is the direction of the acceleration? See, I'm not really trying to solve these. I'm just trying to, so I'm just going to store this in the TI-84 calculator. I love the store feature. There you go. So F equals ma is normally the equation. So therefore F divided by A equals the mass. So therefore F divided by A, store alpha m. So the mass here would be specifically 11.20 kilograms. Once, I don't know if we can ask for that. So there's the mass. So according to this logic, if there's all the resulting force, um, and it accelerates at that direction, which is going to be. All right, let's just answer this. I'm not going to waste time anymore. So anyway, so direction is 1 divided by 42, 10 inverse of that. I'm not going to tell you how to find the direction. You guys can figure that out. Don't even ask me. But I'm just going to use 10 arc 10 inverse of 1 divided by 42, which is 1.36, but that's 180 added to that thing. So it's actually 10 inverse added to 180 of that thing. So the angle between 0 and 2 pi, which is what I'll always state, or I'm going to convert to radians. Where did I? So I did. So everything should be correct. The angle here specifically is going to be 181.3 or 4 degrees. I'm going to store that. So I'm going to store that there. So that means that f cosine of that angle should have exactly negative 42, and f sine of that should have approximately negative 1, which it does. Okay, beautiful. So that matches. What is the mass of the object? Well, so once you get everything else, the mass of the object, I'm not even going to tell you how to solve for that. I'm already way too tired to even explain anything. 11.020 kilograms. Beautiful. All right, that's it. So that's part B. If the object is initially at rest, what is the speed after 10 seconds? Now, I'm going to treat this as linearly. What do I mean by linearly? I'm going to say that forget about the direction. We're just talking about the magnitude. Because the direction will always point, because if this is the resulting force, and it will always point at that direction, and the force is consistent, therefore, the direction will always be at the angle of 181.4 degrees, regardless of the time interval it takes. It's just going to go further in that point in direction. So what I'm going to do is I'm going to take the acceleration at 3.75 meters per second square multiplied by 10, or if you're too lazy, you can put that put a t in the calculator, or you could just look at this and you could say that the speed after 10 seconds it is just asking for the speed, so it's not asking for the direction. After 10 seconds is all you do is multiply by 10, so you should get 37.5 meters per second. Beautiful. What is the velocity components after 10 seconds? Well, that's pretty straightforward, because didn't we just solve for the speed of that thing? So isn't the speed v cosine of theta and b sine of theta? And this is the notation that I like to put myself into. So all you have to do is really just to get the direction is, and I already started my angle, is take that v cosine of theta, however you want to solve it. So what are the velocity components of these? So the velocity components of this is really just going to be, I'm going to put them in the I hat and the j hat notation. So this would be negative 37.49 meters per second in the I hat direction. That's v cosine of theta. V sine of theta would be negative, and I got like, I don't know if that's a known angle or something, but whatever, 89 meters per second in the j hat direction. And we are done, folks. I hope you guys enjoyed this. Forgive me if I suck at explaining everything. But anyways, folks, if you do understand your basic math, your basic trigonometry, you can solve this on your own, folks. So, I mean, these are not hard. These are pretty straightforward. I encourage every single one of you guys never to memorize anything. Don't be an idiot. Learn your trigonometry, learn how to apply, learn where I got the 181.4 degrees, even though I didn't cover that, but you don't need to. All you have to use is some common sense. Apply your SOHCAHTOA. There's this angle reference, or there's a chapter in the bulk of trigonometry that talks about that. I don't even like to read that chapter. Because my brain just gets bored when I read it, or my brain just shuts off. But when you're actually applying it, yeah, you do need to take that into account, folks. So yeah, so make sure you know how to add the 180 degrees added to that degrees. So I mean, folks, you want to build a Star Trek Enterprise, you know? You don't want to. You don't want to memorize. Memorize this. It doesn't get you anywhere. I want good engineers. Okay, anyways, folks, I hope you enjoy. All right, bye.